25% of market share. The next you come to a remaining percentage around like a 20 Google Cloud is owning. The reason behind that, those who have come first, they will become a default type. So that is dominant presence. But now things are happening a little different considering the fact of the generative AI and the big data, the cloud computing, right? What is happening in the industry. So today's topic going to be pretty simple, like infrastructure as a code in a cloud computing. So before we get into the subject, let's do a little brainstorming and I'll just ensure my understanding is right about what you have come across last 3 days. How do you define infrastructure? What do you mean by infrastructure? Because this infrastructure is very close to me. The reason behind industry experience I have around 13 years. So I started my career as an infrastructure engineer, like a desktop administrator. Then I moved into a networking industry, networking administrator. I worked Cisco for Cisco is an organization. They are kind of leaders in networking. I did all the industry certifications. Then I got into a cloud computing. Now I'm a AI consultant with Google Cloud. So that means to say, throughout my career, and I've been working with the infrastructure. So starting from a system administration to computing, if you consider from a bare metal to a virtual machines to a container, Kubernetes, and we are into a serverless, right? So that is the topic we're going to cover second half of the day. So what do you mean by infrastructure in a layman language? Why we are here? Make it a little nice. Let's make it a little interactive. So my present role is a conversational AI architect. When I say conversational AI architect, I'll be designing a generative AI bot. How the bot can act like a human. That means to say when I'm interacting with a human, I need more interaction. Am I right? Are you able to hear me? So you guys are from which college? Same college or different? Different college. So we got all from a different same college or a different college? Different college. Now you'll be able to hear me, right? I'm just ensuring that I'm audible to everyone. Alright, the infrastructure, what do you mean by infrastructure? This is infrastructure, right? We are sitting here. This building itself is infrastructure. And you are sitting in front of a computer, you have a monitor and a CPU, that is also infrastructure. We consider the building, the civil infrastructure, consider a computer as a computing infrastructure. Am I right? So why we are engineering students, why you want to learn about infrastructure? Definitely it is not a civil infrastructure, it will be something about a computing infrastructure. Am I right? So what do you mean by computing infrastructure? I'll ask this way. Hope you all have some computer or laptop at your home, right? If you want to buy a new computer, how will you design a computer? How will you buy a computer? What are things you look? What are the main components? Configuration. Say it louder. Okay. What I mean, basic question, right? So you are studying engineering, maybe like a third year or fourth year, you have post, graduate scholars first. Some of your cousin coming to you and asking, I wanted to buy a computer or a laptop, and how do you search in online or how do you recommend to them? What are the things you look for a computer to buy? It all starts from a computer, right? Today we talked about cloud, tomorrow we talk about supercomputer or quantum computing, anything you can talk, but it all starts from your hand what you are using a computer. How do you find a good computer? Very easiest way to ask the question. Configuration, alright? Purpose is very important. Purpose is very important. What purpose you are buying for it? Is it for a gaming? Is it for a slide? Is it for a app development? Accordingly, you get a computer, right? With respect to the processor, the memory, the hard disk, the antivirus, everything. Can I classify these into 4 categories? One is compute. With respect to the compute, how much speed you need and how much processor you need. Second one is the storage. Are you going to make a huge database? Are you going to run an event-driven application? Are you going to host a web server? So that is the second part is the storage or a database size. The third one is the security. Security in the sense if you are developing something on a computer, then you should have antivirus, right? Protected. And if you are using it for personal purpose, it's fine. If you are developing something, then you should have a security. The fourth one is networking. So without internet connection, there is no use of a computer, right? Think about a mobile. If you are not having an internet connection or a mobile or Wi-Fi or mobile data, there is no use. You will not take out the mobile from a pocket. You take mostly for a WhatsApp install. So that much important. So like 4 core components are compute, storage, security, and network. If you are buying a computer, you will look these all 4 components from your laptop. The same thing only we are having in the cloud computing. When I say cloud computing infrastructure, so that infrastructure piece which covers about these four components. Are we good now? Computing platform. When I say computing platform, with respect to how much processor you need and how many core CPUs you need, these all come to under compute. Storage, what is the database size and how much data you need to save. Then security, what kind of a security mechanism you wanted to place it. The network security or database security, it could be anything. The last one is the connectivity part. When I say connectivity, as a user, how you are connecting a cloud computing, how as an enterprise, how you are connecting a cloud computing. Are we good now? Let me just go to the next slide. This is the agenda for today. I don't want to drag you all into the infrastructure. Let's start with what is happening today. Then we relate why the infrastructure is needed, why we are sitting here, why the cloud computing is becoming predominant component industry today. And then we go with the infrastructure as a code, cloud and GenA era categories of infrastructure as a tools. Under infrastructure also, as I told you, we have many components, right? Compute, networking, security, and storage. So depends on these categories, we have a different types of tools. We'll pick one particular tool, then we'll go in depth and analyze and understand the tools, and we'll do some hands-on labs with the particular tool. So that tool we call it as a Terraform. Alright, so next I will go back to the next slide. When I go back here and I'll get back to infrastructure back. I will start from here. For latecomers, we're just starting it. We just got to know each other and we're just starting it. So this picture or this slide is self-explanatory, right? I don't want to explain anything. And these are the four industry revolutions. Which revolution we are today? First, second, third, or fourth? Pretty simple answer, right? Try, faculty members, please bear with me. I used to ask many questions, and I know you used to ask a question. I'll ask a question to you. Sorry. And we are in the fourth industry revolution. When I say fourth industry revolution, it's mostly about your what we are doing today. Artificial intelligence, IoT, neural networks. So that is a trending area, right? Today, everywhere we go, artificial intelligence, refrigerator with AI, washing machine with AI, ChatGPT, Gemini, everywhere AI. Whatever you do today, it's all with the AI you'll be doing it. So we are into the fourth industry revolution. So fourth industry revolution is very close to a human society. So that's the reason we'll be emphasizing more into AI development like ethical AI, responsible AI, the deep fake. So the fourth industry revolution is so fast as well as it is kind of so threat to human society. If you mishandle the fourth revolution technology, it will completely destroy the humanity. So the fourth industry revolution or the Gen AI, we can consider the example. It's kind of a double-edged sword. So it's like two sharp swords you need to have handle carefully. I'll just ask you one more question. Since when I put in a previous slide about the fourth industry revolution, some of you already told the AI is a technology trending today, right? Any idea the business value of a Gen AI technology can bring in next 1 year? Do you have any idea? The reason I'm asking this question, so today we are learning it here, we'll do some hands-on, but at the end of the day, how you are making money, how we are making money using technology, that really matters, right? How we are improving your productivity, how you are utilizing technology to solve a problem, a business problem. So that's the place you will be getting a revenue. So like the example I could ask, how many of you use ChatGPT? Almost everybody, right? Do you think that ChatGPT has been invented for you to only use? What is the main purpose they have invented such kind of app? Not for the individual users or subscribers, right? Their main focus is the industry side where they will be getting a huge revenue when the people started, doing a microservice or API integration with the use cases. So the industry revenue is the main use case whenever you launch any new technologies. Even cloud computing also. Why AWS is giving a cloud computing service or Google is giving cloud computing service? End of the day, they want to make money out of it. Can you give me an answer or any guess? So, from a technology called generative AI alone, we could able to generate a value of 4.4 trillion revenue in a year. So that is more than our India's GDP. Do you know India's GDP how much? Any guess? Maybe the first row you can see. So India's GDP as per July 2024, it is 3.9 trillion dollars. So generative AI is a technology. Nowhere we have seen this kind of a technology will come and make a revenue in a short period this much huge. So that means to say this adoption is happening in every industry. When this adoption is happening in every industry, to make that adoption, what is the role of infrastructure? What is the role of cloud computing? That is the connecting points what we are going to discuss. Are you good now so far? So generative AI is a very tricky technology which is going to make a revenue change. So whatever the figure I have shown here. And just to add some more proof to the point what I highlighted before, with the Gen AI technology, the whole industry automation is happening a decade back. It's getting preponed to. It was supposed to get happen on 2040 here. You could see here 2040 it's supposed to be expected with all the existing technology what we have till we get a Gen AI as a technology. After this Gen AI's adoption, this industry automation is drifted 10 years before from 2040 to 2030. Only thing here is, according to the latest survey, the Boston Global Group, last month they released a survey, and we are not having a skilled resources to achieve that. The technology is getting more skilled, but people are not getting skilled. So that is how I could show you some statistics. And this is all about the Gen AI. This is a hyper cycle. You know about what is happening with the hype of the cycle Gen AI and augmented, software engineering, and you have AGI. All this comes. Now, cloud computing, I'll come to the cloud computing part. And there is my AS. I'll go with this slide. Since we started with AI, let me go with AI. And anybody gets the answer? So we keep hearing AI as a technology today, right? When the first time the AI has been introduced, the term 1956. I know faculty are there. They must know about the answer 1956. And so that means to say almost 68 years back the term or the technology has been introduced. But is it so popular for 10 years back or 5 years back? If that would be the case, everybody would have studied AI, right? Everybody would have studied AI into a school curriculum. But AI is so popular for past couple of years, or past 4 years, I would say. Maybe after this, all this comes in. Do you know the answer why AI is so popular today? First, do you agree with me? AI is so popular today? Yes or no? Yes, no doubt. It's been there for 68 years, but AI is so popular today or past couple of years. That's the reason we could say the AICTE is approving a lot of ML department, AI department, data science department. The specialization is happening now, right? Any guess why AI is so popular today? Little louder. Generative AI infrastructure. Yeah, now we have a good infrastructure. That would say like AI is becoming so popular. Generative AI is making a lot of changes. It is easily adaptable. To answer that question, this is a very fundamental slide what I have it. Okay, this is like ABC. When I say ABC, so we used to start always from a kid. We used to start from ABC, right? Before we start telling any word. The similar way, the technology when you take today, if you are studying something or if you wanted to work something on a technology, this ABC is very fundamental. Say A everywhere. So if you call it as the Gen AI or yesterday's traditional or a predictive AI, whatever the AI use case if you take, the fundamental will be big data and cloud computing. So if you wanted to have a powerful AI, then you should have a very powerful data set. When I say powerful data set, powerful tokens, huge size of a data, the clean data, the data pre-processing. So data plays a very vital role. The same way, when you have a huge data, then you should definitely need a computing power also to do a processing. Am I right? You want to develop a huge computing model. Have you ever developed a machine learning model? Do you know about the TensorFlow? Anywhere? Okay, fine. If you want to develop a machine learning model, how the machine learning model works? So machine learning or artificial intelligence is the end of the day. You are going to make this computer to mimic like a human. Do you agree? So that's all right. So artificial intelligence is you are going to bring your intelligence to a computer. That's all. So to make that happen, you are going to train a computer. To train a computer, you need a data and computing. Are we good now? So that is the same thing here. So ABC when I call it as artificial intelligence. If you want to have a powerful AI device, you should have a big data and cloud computing. That's the prime reason if you say any AI component, AI release is happening, those are completely from a cloud providers. ChatGPT, OpenAI from Microsoft, Gemini from Google, Anthropic. If you take any AI tool what we use it today, that is definitely hosted in the cloud computing. Do you all agree to that? Do you all agree? See, now I'm connecting the dots. So you are in today, you are using almost everybody raise hand, you are using ChatGPT or any Gemini tool. But though you are using GenAI tool as a front end, to happen the tool operation, you need a backend. So that backend is completely managed by cloud computing. So that cloud computing has the four core components: compute, storage, security, and network. When things are becoming big, when the things are becoming so agile, so fast, so scalable, then doing manual process will not work out. Do you all agree? Then we need to automate that infrastructure. That's the reason the infrastructure as a code becoming so trend. Are you getting an idea why we are here today to talk about the this sorry now I have placed this slide on the car. However, I'll go back and start from the traditional idea. Now, so far in the agenda, so we touched upon these what is happening with the infrastructure as a code in the cloud and GenAI era. So GenAI is a training technology. To understand GenAI, you should always remember the basic fundamental rule ABC. Can you all repeat with me what is A stands for? B stands for? C stands for? Please bear with me, the last two. Alright? Okay, now we'll come back to actual infrastructure. So today we talk about GenAI and we talk about big data, we talk about cloud computing, everything, right? But if you are using something today, but there was something yesterday. When you talk about WhatsApp, Insta today, it was like Orkut, Facebook, or even we have only a text message. Not something back. Right? We used to communicate only the text message, no such app like a WhatsApp or Insta or Telegram. So the same way, when you want to understand the modern infrastructure, then you should have an understanding about yesterday's infrastructure and what are the pain points, what are the challenges, why we are moving to a modern infrastructure and why we are making that infrastructure and a code. Now this is a typical way the IT industry works. I mean, rather than I go with the IT industry, I'll ask you the very basic question. And say like you are working on your final year project, and your department asking you to develop an app for your department. And if you want to develop an application for your department to monitor your students' progress, so how do you start making the app? Say like rather than go with the app, just consider you are going to make a website. How do you start? This is a business requirement I'm giving to you. How do you start the work? You do a data collection, then you do a data collection, then to run an app or a website, you need a platform, right? You need to host either in your web server, I need to buy a separate server from your department fund, ask your HOD, give me a fund, I need to buy this CPU, or I need to host my server into a cloud. So these are the things you ask. This is a typical way every industry works. The customer, when I say customer, they may do any business. They may do a pharmaceutical or automobile, any business they do. They come to our industry, they say that, hey, I have a problem, can you give me a solution? So this is the typical way. So we are a problem solvers, we are a solution givers, any industry. Then when the time the business comes with a problem to a business analyst take that solution, give to the solution architect. What the solution architect will do, okay, fine, this is your requirement, fine, you wanted to develop a public web server, website for a department, okay, expecting a traffic per day, 1,000 hits, fine. Then you wanted to have a front end, you want to have a back end, how much database, and who all have the admin access. These are the things you will define and you will design that website architecture. Similarly, in the solution architecture, we will be designing, okay, for this problem to solve, I need to define a web server or I need to define an infrastructure. So that infrastructure will host all these things. Your platform server, your, like again the four core components, your computing, your storage, your security and network. All these things you will procure it. When I say procure, you will take a procurement request and you will go for approval, you buy everything, then you will install it. After installing it, you will put patches, the operating system, everything you do. Then after some time, your infrastructure will be ready for your development work to start. Are you getting it? So till we are in the phase of creating an infrastructure for an application to be developed. To creating an infrastructure itself, if you go with it, in a production environment, this process will take 2 to 3 months. Just imagine 2 to 3 months. If you are waiting for the infrastructure to be developed, then it will be really a good thing or a bad thing. It's really a bad thing, right? Then it has a lot of limitations and problems. This is the challenges what we had yesterday when we typically work with a traditional data centers or a traditional environment infrastructure. So it will be a very slow deployment, 2-3 times for the servers to get ready to deploy your app, to deploy or host your website. then it is too expensive. When I say too expensive, so you will be hosting all this infrastructure, but you are not going to consume all the resources. Like a 10% or 20% you will be consuming it. Remaining everything will sit idle. Then it is too expensive. Limited automation. So with respect to your requirement or scalability, you need to increase it. And there is a probability of a human error, wasted resources, inconsistency. There are a lot of drawbacks when you go with any of the traditional data centers. Then what will be the solution? When I said if you want to develop something on a like IT industry, then you should go with this life cycle. You need to go and procure everything, install everything, compute, backup, storage, DRS, then antivirus patches, operating system. Then once you have application ready, you will be installing the application. So this setup has these are the limitations or drawbacks. How do we overcome that? Yeah, one solution is pretty simple to overcome all these things. I just put a one crash market to overcome all these things. You need to go with the cloud. So cloud computing maybe with any of the cloud providers. I put the largest three cloud providers in the world. So they are AWS, Azure, and GCP. Are we good now? Why we are going to a cloud computing? There are two reasons. First reason I told you about ABC. So that is happening today. Gen AI, if you want to develop, you should definitely have a cloud computing. You agree with me? Definitely, that is the one thing. But yesterday there was no Gen AI. Yesterday it was matter of developing application, matter of developing a website, developing anything else like a predictive ML model or anything whatever you do with yesterday. So yesterday's challenges was creating an application itself very challenging, creating infrastructure. To overcome all this, the cloud computing. I hope you all have studied cloud computing as a subject. Am I right? The students at least? I know staff faculty know the things, and if you have studied cloud computing as a subject, you know the fundamentals, everything, right? Fine. Now. And I go with the cloud computing stuff. Then cloud computing, this you know. So cloud computing is basically one analogy, one example. Then I'll just move to the next topic. So cloud computing is basically like owning your own car. So you need to take care of everything, right? Having your own car or hiring a cab, which is better. So if you want to communicate from college to home, having your own car or hiring a cab, which is better? Having your own car is better in some aspect, or hiring a cab, or taking an auto or going with a bus, whichever is better, right? When you go with the shared resources, then definitely that is better. If you are having your own car, just hypothetically think, then you should take care of your initial investment, the parking space, insurance, operational expenses, what else? There are a lot of things you need to take care of it, right? Driving on the road, everything you have to be very conscious. You can have to watch on your mobile and go, and it makes life so inconvenient. If you go with the cloud, just matter of taking an app, and probably Ola Uber we never have mostly in our place, right? Do we have Ola Uber in our build? No, right? And we may use like on the way cab or auto. And then if that is the case, you'll be just pay for what you use. So that is the basic thumb rule why we go with the cloud computing. And this slide. So what does it mean by what it says? Do you all see the slide? I mean this website. This is a Google search. Whatever you type and it will answer to you. But what is actually important here? So this is actually important. What is the difference between the previous slide and this slide?
That's what we see.
This is what actually. This is the front end. What you use it on your tool, or your mobile or computer. But this is actually what is happening in the background. This background, whatever I'm highlighting here, right, that is actually called as infrastructure. This infrastructure, whatever it will place here, it consists of your computing, your storage, your network, and security. We're going to automate all these things. So why you want to automate infrastructure? The reason behind the infrastructure load will be keep increasing. So like any app you take, so the load will be automatic, always will get increased. And if your app is really popular, the load will go exponential growth. Then you need to take care of the scalability, high availability, elasticity. You know all this stuff, right? The future expansion, ensuring the DRS, ensuring the backup, low response time. These are all the things you need to take care of it. If you are having a traditional data center, then you need to go manually do all these things. If it is a cloud computing also, we have a cloud computing also, you have an infrastructure as a manual process, infrastructure is a code. Infrastructure manual process, again you need a manual intervention. Infrastructure is a code, no. You're just making a code for that. When you say a code, It is not so much depth into a programming language what we used to do for a computer to understand our language. It is more about the cloud to understand our language. You know the difference what I am trying to explain? Infrastructure is a code and the computer programming language is different. So basically computing, what are the programming language you study? Python, so popular, like Python you study, Java, oops, anything you call it as, right? C++, Ruby, anything you say. So those are the languages you use to communicate with the computer. So that computer will understand what you are trying to say in the computer. So now that itself becoming easy by using NLP, you can talk to a computer in your own language. So prompt engineering, right? So computer can understand what humans are talking, it will extract the intent, entities, and it will answer you. So that is a different thing. Now, to interact with the computer, you should know a computer language. Now, to interact with the infrastructure, you need to have an infrastructure as a language. That infrastructure language, what I'm saying, that will be very simple, declarative. Because you are not going to talk to a computer, you are going to talk to a computing resource, the cloud computing. So C, C++, Java, Python, if you want to develop any application on my computer, I definitely need that language. So that computer will understand what I'm trying to explain. Now this infrastructure is a code. You are a practitioner, you are developing a code. The end of the day, the code has to go and talk to a cloud computing. So the cloud computing understanding is very easy. The language what you are going to use, that is not something HCL we will discuss today. And that is unlike other computing language, the infrastructure as a code language is pretty straightforward and it is easily understandable by resources and computing platform. Are we good now? Just giving the difference between what is the infrastructure as a code. And if you have studied cloud computing, you know these differences like SaaS, PaaS, and infrastructure service IaC. Infrastructure is a code and infrastructure, when we name it as an infrastructure, what are the four cloud components? For compute, storage, security, and network. The four core components, right? When I say compute consists of your processor, your memory, then your hard disk, and also your operating system. Your enhancement is all will come to a computing side. Storage, your database size, and again, security and network. How you are accessing it, how you are preventing, or how you are protecting your infrastructure. This comes to play a role. So, if you consider any cloud platform, so these are the things we are going to explore today, the infrastructure side. And why cloud computing? The reason we discussed two things, right? One is the challenge from a traditional data center, other one is from a GenAI perspective. So traditional data center, why we are going to cloud? Any one reason? Can you say a little loud? I'm getting only schisms. I mean, so before we go into the cloud computing, the basic thumb rule I'm asking, there are two reasons we discussed. One is the ABC triangle. Do you remember the ABC triangle? So with respect to ABC, why you are going to cloud computing? What actually mean by ABC? Exactly. So if you have to have a powerful AI, you should have a powerful computing to have process of big data. So that is the one reason. Now, like earlier, the cloud computing used to be considered as a cost-effective center. When I say cost-effective center, if a traditional organization running a data center, it has a huge expense. To minimize the expense, people started using cloud computing. Now with the AI era, Gen AI trend, the cloud computing is more than the cost minimizing center. It is considered as a cost generative platform. When you say cost generative platform, if you wanted to make use of your data, you should get a cloud computing. Anything you want to do automation, it will generate a revenue. If you want to develop a virtual AI bot, or if you wanted to integrate anything with the generative AI models, you need a cloud computing platform. So cloud computing is drifting from a cost-effective platform to a revenue-generating platform now. Are we good now? So why the cloud computing is becoming so important in the AI industry, AI era? That's what I'm highlighting the difference. Traditionally, it used to be considered, okay, if I go to cloud computing, I can save a cost. If I go to cloud computing, somebody else will take care of my infrastructure. I don't need to I don't need to worry about anything. That is the prime reason the cloud computing been introduced. Now the magic what cloud is doing to this ABC, the artificial intelligence, Gen AI, your automation, your virtual AI part, the cloud computing being considered as a revenue generating platform. And these are the reasons why we go with the cloud computing. High availability, agility, fault tolerance, global reach, predictive cost, scalability, elasticity, DRS, productivity and security. These all you know it, right? I don't want to repeat the theory part. This is typically the cloud computing resources will looks like. And we started with our local computer, which has all four components. But cloud computing is definitely there is a computer, but the computer owned by somebody. The computers are managed by somebody. You will pay for only what you use. So exactly like rather than owning your own car, you will be just pay for what you use for a trip. Your Ola, Uber, you just take a trip, pay for it, and go. So this is the way typically it looks like, and. So this again, so BAL is dominated by software, the software is getting dominated by AI. To run AI, you need this we discussed the ABC. Now, we'll come back to our infrastructure as a cloud, our infrastructure tool categories. Just a quick recap of what we discussed so far. We started with traditional infrastructure and what are the limitations or the challenges of traditional data centers. Slow down. Traditional data centers, cost expensive, and we're not using the complete resources, and not stability, scalability. That's the main reason we go for a cloud. The cloud also we have other advantages. It is being considered as a revenue generating platform now. And cloud we have been having those four components only: compute, platform, compute, network, security, and database or storage. Now, infrastructure tool category. So this is the main topic, the infrastructure as a code. When I say infrastructure as a code, not necessarily the infrastructure should be a cloud infrastructure. The infrastructure can be an on-prem infrastructure also. Do you know the difference between what is on-prem, what is cloud? On-prem is like what we have it here, right? The individual computers, we have a rack room, the connection goes there, we have a server, this is the on-prem. Cloud computing is you're just opening a browser, you're accessing a virtual machine somewhere from a cloud computing platform. That is the main difference if you consider. Now, infrastructure as a code will be having three categories. And infrastructure as a code applicable for both the industries, both the sites, on-prem as well as the cloud. Since the cloud is predominantly used for all your deployment, development in industry, so no more on-prem deployment is happening. So we are not concentrating anything on a on-prem infrastructure as a code. That doesn't mean that it is not applicable. It's still applicable, but we never do that. And go to a cloud computing side. The cloud computing side when I go, as we discussed again the four core components: compute, storage. I know I keep repeating it because that's the reason we can get a clear idea about this. Computing, storage, security, networking. We have three categories. When you consider the three categories, first one is the configuration management, second one is the server templating, third one is the infrastructure provisioning. So configuration management. So configuration management in the sense, if you wanted to develop an application or a web server or website, you should have a server to build. So what do you mean by server? Before I go there, what do you mean by server? What do you mean by client? Sorry, can you say it aloud? Yeah, the device which provides service to the client, those are called as a server. Where you are hosting your application, the hosting a domain, the hosting the purpose, it is always called as a server. And where you are accessing from here, that is called as a client. Always on a topology, the server remains very minimal and the clients will be more. Say like if you are using a Gmail, so we are client users using a Gmail using username and password. The Gmail server hosted somewhere in the data center, that will be considered as a data center. We never know where it has been hosted. You agree? So that way we go. The first one is configuration management. So configuration management in an infrastructure. So infrastructure, now we got a clear idea. So infrastructure is something, before you develop your code, you should have a platform ready, that is called as the infrastructure. So infrastructure can be an on-prem or it can be under cloud computing also, but we will be concentrating only on the cloud computing. Cloud computing infrastructure automation, we have three categories. First one is the configuration management, second one is the server templating, third one is the infrastructure automation. We go and discuss about the first one, the configuration management. So configuration management is more about building a computer. When I say building a computer, and we have a computer ready, you are buying a computer from a shop, but this is a brand new computer. It doesn't have any operating system installed. I'll say like it has only Windows 10 installed. But once you bought a computer to home, what you do? You install your applications, right? You install your browser. You may install, some movie players. You may install some different application what you wanted to use on your computer. That way you do. If you wanted to do such configuration, the cloud computing, we will be calling that as a configuration management. That configuration management inside the server. When I say inside the server can be a Windows server or Linux server, or it can be any open source server. So that is taken care by some of the tools called Ansible, Chef, Puppet. Did you hear these terms before? Yes. Okay, you know about the terms. Good. The second one is server templating. Server templating is, no, I don't want to do individually on a server level configuration. Rather, I can package the server. I can just deploy a package, deploy a container, deploy a Docker. So that will come to the server templating. When I say server templating, you just ask a server templating tool like I need a server to build a this particular website. I need a server to build a mobile app. I need a server to build a mobile app for Android. I need a server to build a mobile app for iOS. If you have such provisions available, so it has a pre-packaged with all the prerequisites. When I say prerequisites, and if you want to develop a small website from your local PC, sometimes you need to install a .NET framework, you need to have a SQL servers installed to access everything from a local instance. So rather than doing everything manually, if you package everything together, just deploy. That is called the server templating, which is taken care of Dockers and packages. So this is more about, first one is you have a computer installed, inside the computer what you are installing. Then the server templating. The server template can be with any versions, how you are deploying. The last one is the infrastructure provisioning. This here we will be considering more. The infrastructure provisioning, it is not only about the computing, it is about the computing, it is about the network, it is about the security, it is about the storage as well. Are we good now? So why I keep telling the 4 points again? So these two configuration are a DevOps, mostly concentrated on the computing platform. Here are mostly the Dockers, Kubernetes, containers, OpenShift, serverless, anything will come here. These two categories. Infrastructure, it's not only limiting a computing platform. Other than a computing platform, it covers your other components as well. It can be a storage or security or networks. Are we good now? So here there are two tools I have highlighted. One is Terraform, other one is CloudFormation. So CloudFormation is mostly like a tool which is inbuilt inside the AWS cloud computing platform. And Terraform is the open source platform which anybody can access and they can play around with. And now, the last one what we are going to discuss, the infrastructure provisioning. The infrastructure provisioning which will cover all the four core components, computing, storage, network and security on a cloud computing platform we basically going to talk about. So to do that, we will be exploring the next tool called Terraform. So why we need infrastructure as a core? Why we need IaC? So we discussed the pain points of traditional data centers, and we discussed why we need to go for a cloud computing. Now, why we need to do automation? Any automation, why we need? If you consider any automation, say like attendance system, to make the work faster, right? To minimize our human effort, to maximize the system performance, we'll be going with automation. That could be any automation. Maybe today is how you are taking help from an AI tool to make the work happen very quick. Could be a PowerPoint generation or any assignment or anything, whatever you do. The end of the day, automation is making your life easy to make the system to productively work as a max. And in infrastructure, if you go the similar way, you are developing an app today, and say example, the trending one, take a Gemini or a ChatGPT as example. So when they launch, they may expect a traffic of 1 million to 10 million. But after a month, the performance reached peak. They just wanted to increase the infrastructure to 100 million users or 100 billion users, assuming a use case. Then they will restrict, okay fine, if I go beyond this much resources, then I will be consumed for more cost. Then I will charge the people for a subscription basis. This is the way the industry works. When the requirement goes, when the demand goes, then you need to keep increase the infrastructure also accordingly. But if you manually do such way, do you think that is the effective way to do that? then it has a manual intervention, then we are prone to do a mistake, then there are a lot of difficulties when you do manually. To overcome all these things, we go with the IaC, we can automate, and also the declarative. When I say declarative, and why? Okay, I'll ask you this question: why the GenAI tool is so popular? Like Chat GPT or Gemini, whatever you use it today. Can you tell me why it is so popular? Specific. It gives specific information. Okay, it gives a specific information. That means after you exploring, you are realizing that it gives a specific information. Why it is becoming so popular? Why everybody is using? It is response to human language, right? I mean, so the technology at the end of the day, which is very close to human, that will be a super hit. That will be called as a cognitive science. If you have the term cognitive science, human brain will think a way, psychology, physiology, psychology, philosophy, and computer science. This all whatever we see in the world, we manipulate in our brain, then we take a decision. The ChatGPT kind of a GenAI tool, why it becomes so popular? Because it is giving very user friendly to the end user. When I say very user friendly, you're just asking only in your normal English. It understands what you're asking with NLP, responding back to you. That is the primary reason. That is the main difference. What is GenAI mainly, becoming so popular? The reason one is it is understanding the natural language. The second reason would be it could be able to generate what humans are generating, the text generation or image generation or content generation. That should be the second reason. So declarative means when you are developing a Terraform code, when you are developing a CloudFormation code or any information as a code, so that code doesn't need a computer language expertise. You getting it right? I mean, when I say ChatGPT is so popular, everybody is using it. When I say everybody is using, even an illiterate can also use it, right? But if we say the Python or a computer programming language, only a programmer can use it. So that is restricted to only the programming category, not a mechanical student can use it. I'm just saying the example. That's it. If you go the declarative, so this declarative is just you are declaring what you need to do for automation. That is completely understandable by the cloud resources. So when I say code automation, I'll do a code automation from my computer. Then I'll be accessing a GCP cloud or a Azure cloud, and I'm just writing a infrastructure as a code in a declarative language. When I say declarative language, it's a straight NLP language which goes to a Terraform database. Terraform database, it has that conversion. If I get this code like this, how do I call an API? I'll come to the API part again. So when you write a code, it will go to a Terraform backend. Terraform again call the API to the cloud resources. Then it just done the work for you. And it is rollback is easy, validate, scale. So these are the things what you can do with the IaC. So IaC is not no more optional. It is becoming mandatory now. And again the same example, Terraform. So Terraform, it is used for provisioning. It is immutable, declarative, and we use a language called HCL. Anybody has a previous exposure to the Terraform? Anyone here? HCL. HashiCorp is the like open source community. They have developed this particular platform. Terraform is completely a open source platform, and it is supported by multi-cloud, and it will support around like a 70 different providers. It is not specific to one particular platform. And you can use, if you know how to operate a Terraform, it's one of the tools. You can use it for any cloud what you work upon, and not only about a cloud. If you want to automate your GitHub, if you want to automate any of your CodeShell or Acura, you can directly get integrated with it. And it supports 70 provisioning servers. The language or the programming, whatever you use in the Terraform, called as secret configuration language. So that is the we'll discuss more. Like that is kind of how it is declarative, how it is easily understandable by human. It's likely a prompt engineering kind of a thing, but not like a plain English. It is something specific to that particular cloud provider whom you are operating. But what the cloud providers are doing it, they are giving all their bundles to you. So if you are using Terraform, fine. I am giving my models to you. This is the module. This is the code base for my components to configure. For a GCP cloud, if you want to develop a computer, then you can have a code from Terraform. You can just place and run it. Then it will create a computer. Rather than if you wanted to create a computer, 100 computer for 100 resources, rather than you go and deploy it 100 times, you can copy a code. You can just put it here, run for 100 times, write a script. Then 100 computers will be deployed immediately. Are you getting what I'm trying to say? So this is the way you can make the infrastructure automation is very simple using HCL. And okay, this is more about a Terraform what I discussed. It is about having a multi-cloud or multiple API support and core open source and enterprise support. And I'll show you where actually you see this. Yeah. If you look at this website, so this clearly shows what are the tools being primarily used for DevOps. And do you all know about DevOps? Development students also know about DevOps, right? Developer lifecycle DevOps, developer operations, right? So to make the DevOps happen, so there are many tools. And if you go with the configuration and automation, which is blue in color, so that blue in color tools, it has something called a Red Hat, Ansible, that is for a configuration management we discussed. Then you have a Chef, the similar way for a configuration management. Then you have a classic crop, Terraform. So this is completely for an infrastructure management. So when I say infrastructure management, so that infrastructure not necessarily to be a cloud computing platform always. It could be a on-prem or it could be a cloud computing. But due to the popularity and utilization of a cloud computing, we primarily use for a cloud computing. So when I say cloud computing, I am a practitioner. I'm writing a Terraform code from my computer. It has a Terraform provisioning in between. Then it goes and deploy resources of the cloud computing. Right? So this is the way I just want to highlight. This is actually what we discussing here. Let me just go back. And the advantages of Terraform would be, as we discussed, it supports multi-cloud. It is not specific to one cloud computing platform. Whereas if you go with a particular cloud like AWS, they have a cloud formation specific to AWS. If you go with a GCP, we have an infra manager which is specific to GCP platform. So every computing platform also they have their specific their automation tool. But the reason what is happening, the trend what is happening in the industry, not the customer is depending on one particular cloud computing. So cloud computing also there could be a possibility the outage can happen. So almost every customers or every industries they are going with a multi-cloud. When I say multi-cloud, every customer will be having certain components running on a GCP, certain on a AWS, and certain things on Azure. So if you are going with a multi-cloud deployment, then you should have a one unique tool to operate all the cloud computing platform. Does it make sense, right? Rather than you have a cloud-specific tool to get operate, you can have one common tool which can be applicable to multi-cloud. That's the reason we go with the Terraform kind of open source, and it has a support from all the cloud providers. If your Terraform code is not running in case in the production, so you can log a ticket with the cloud providers; they will support you, and it has a larger community since it is open source. This is more about how we get a support. Now, this is the architecture what I was explaining. Now, just a quick recap. So Terraform is an open source coding tool or automation tool where you will be doing a code in a Terraform backend. It has a provision of all the cloud APIs. The moment you do a code and deploy a code into a Terraform platform, it does the automation to a complete cloud computing platform by calling the APIs. You know about API, right? What do you mean by API? Application Programming Interface. What it does? What it does? Say it in louder.
It acts as an interface between two.
It acts as an interface between two entities, right? I mean, if you want to understand more about API, you are saying something. It is a middleware, not actually the middleware. And what actually does, it does a connection from if you are developing a middleware, it does a connection from a middleware to other resources. Again, more understanding about the API, then you should know about the software architecture, right? There is a monolithic architecture and microservices architecture. So monolithic, all the components in one physical server, that is called as a monolithic. If you go with the microservices, different services running with a different platform or different places, you are just integrating that using an application programming interface. So that actually called as the API. So now in Terraform also, Terraform has the API interface to all the cloud providers. Say like a 70 provider, they have an API. And they have a code base also for every cloud provider. What you will be doing it here from your computer, you will be creating a script by using a Terraform declarative language that is called as HCL. Once you write that code, that will be very easy to write. Then you will be deploy or run that code into a Terraform platform. So that Terraform will call the API to a cloud computing resource and deploy resources. Same thing. So practitioner is an engineer or you and me who will be developing a code here. So when you have a code ready, then you go. I mean, basically when you are deploying a code, when you are running any computer program, you go debugging and running. Right. Similarly, for a IaC code, we need to validate, plan, and apply. So when you do such thing, then it will go and check this code. What I am trying to do it from my computer belongs to which platform? Is it to a GCP or Azure or AWS or a Kubernetes or which should be? I mean, which VMware or any platform which it's supposed to be. Then accordingly, if it is a GCP, then from a GCP from apply, it will go to a GCP. Then GCP will create a infrastructure resources, computing, storage. So how does it happen? When you write a code here in a declarative language, it goes to a Terraform backend. So Terraform backend has the API calls to all the cloud platforms. So this communication, this aroma, it does the API calls, the application programming interface, the REST APIs mainly. Then the computing platform, it will be, the cloud computing platform just deploy the resources. Are we good? This architecture or flow? Any doubts? The same thing will be going to do in the lab. I wanted to ensure you understand this concept. So infrastructure as a code, are we good now? So I'll move to next one. So same thing like when I say 70 plus Terraform providers, this is actually called as a Terraform providers. So a few of them are placed it here. But at the end of the day, you'll be writing a code from your computer. After installing a Terraform package on your computer, you'll be writing a code from a Terraform. Then you apply and just you just save, validate, and apply. And the moment you apply, it goes to a Terraform backend. It checks, okay, what is the supposed, the equivalent API calls for this particular, declarative language what you define here. This code go and call this API. Then API is called the, your cloud computing resources. Then your cloud computing resource will deploy an infrastructure. The infrastructure can be a computing or it can be a storage or networking or security. Rather than restricting yourself only with the computing, when you say computing, your Ansible, Chef, Puppet, or a container, Kubernetes, those will come only for a computing platform. But infrastructure is not only about the computing. Other than computing, it has other components as well. The 4 components, right? Networking, security, and database. So that way it goes on. So different cloud providers. So Oracle Cloud, Alibaba Cloud, Kubernetes, and you could integrate these with Apache, Grafana, and GitLab. And we go to that. So this is the actual, the exercise what we're going to do here. So before we go to a demo or a lab, do you have any doubts so far? Where we started with infrastructure as a code and what is Terraform? Any doubts? Are we good now, right? So now, just a recall. We started with the cloud computing platform, and the cloud computing platform. One of the reasons we go into cloud computing, there are 2 main reasons. One is the legacy reasons. We go for a cost-effective way, and scalability, elasticity, agile, fault tolerance, everything will be taken care of by cloud computing. Now with the trend of AI, more than cost-effective way of seeing a cloud computing is becoming a way of cost-generating platform. So yesterday or today, the cloud remains same. It is becoming very popular with the AI also. So that's the reason we understood the foundation of ABC, artificial intelligence, big data, and cloud computing. Now we go with the cloud computing. So cloud computing primarily hosts 4 main resources: compute, storage, network, and security. And when we call these 4 components as an infrastructure, deploying this infrastructure manually also a challenge, even with the on-prem or a cloud computing. When the load increases, if you wanted to expand, if you wanted to drastically increase your infrastructure, also will be a challenge. That's the main reason we go with this infrastructure as a core tool. And infrastructure as a core tool, we have 3 major categories. One is for configuration management inside the computing server. Second one is deploying a package server. Third one is deploying or automating an infrastructure itself. So we will be focusing more into infrastructure. That's a topic we will be discussing. So when you want to discuss more into infrastructure, we have 2 options. One is Terraform open source, and one is a cloud formation specific to AWS cloud. Similarly, we have a cloud automation manager for a GCP. And we'll be touching the Terraform. So Terraform is a provisioning tool which will be running the declarative, and you can run the Terraform code with HCL. And it support. I just mentioned the Google Cloud support. It is supported almost by 70 providers, and those providers highlighted here. This is the providers starting from all the major providers to all the platforms where you integrate the infrastructure. This is the architecture of the flow. Whatever the code you deploy from your computer, you just validate, plan, and apply. Then it goes and access to the cloud computing platform by calling an API. Then the respective resources will get deployed. Are we good now? Now, so now the one example, if you go with a computer, again, when you want to understand the cloud computing instances and a computing platform, we should have a same understanding with our own laptop. Have you ever created any computing instance in any of the cloud platforms, like AWS EC2 or Azure or computing engine at GCP? Yes or no? No, fine. And but you at least configure the laptop from scratch. I mean, when you buy a new laptop from a shop, what do you do first? When you buy a new laptop from a shop, or you're just ordering a brand new laptop from Amazon, which is getting everywhere. First, installing your OS, fine. So you're installing your OS, perfect. But installing the required software, right? What do you do then? You configure the user accounts, right? You don't have one account or a two account. If you doesn't have an antivirus, you install antivirus. Then you connect to your Wi-Fi. Connect to Wi-Fi by giving it credentials. So that means you say when a brand new computer arrives at your home, you need to do some certain configuration on your computer. Say like creating a user account. User account means you are just defining that who needs to have access to my computer. You getting my point? So you're creating a different profile. That means to say the different people having a different level of access to your computer. Those who are not knowing the password for the computer, they will not access it. They cannot access your computer. That's the first thing you will do. Then you install your required softwares. Then you connect to a network. Network, you are defining who has the access to your computer. Or from your computer, what things you can access it. Similarly, in a cloud computing also, when you are deploying a computing instance, deploying a computing instance in the cloud computing exactly equal to how you are buying a new computer. So to deploy a computer, you need to have a network ready first. You should have a network first predefined. So it's like in a home, when you buy a computer, you are connecting a Wi-Fi network which already exists in your home. So that means to say before your computer, you are already having a Wi-Fi. Or after buying a computer also, you can just have a Wi-Fi or a network ready. Once you have a network only, you can able to connect. You agree? Same way, if you want to develop a compute instance in a cloud computing platform, you need to have a first the subnet needs to be created, and the subnet means network. Then you need to define which zone and which region. The zones and region which will come to play a role in a cloud computing, because cloud computing is a global platform. So we will be operating a cloud computing from across the globe. Say like I'm creating a cloud computing instance, a computing engine from India, from Kanyakumari. If I'm creating an engine or creating a computing instance, then I can closely deploy that into a nearest zone and nearest region. When I say zones and region, the cloud computing has a lot of regions. Say like a region would be US one region, Europe, then Middle East, then APAC, 4 regions. Under region, they will be having multiple zones. Under zones, you can configure your particular instances. So the why we are configuring or why we are going with the region, zones, and networks. The reason to avoid the latency issues. We say the latency issues. For example, if you are accessing a Google search engine page, you just go to a browser, you type a Google, right? When you type google.com, how it opens? Any guess? When you type google.com, what actually happens in the backend? It sends a request to the server. Then which is a nearby geography request server, what you get, then you will get open, right? And little if you go in little more depth, so the moment you type google.com and give enter, your browser from HTTPS traffic, it just generated DNS request from your laptop. Your DNS request will go to your DNS server, which network you are using it from like provider. Say like I'm using ATAL or I'm using Geo network here. It will go to a network. The network will just query for, okay, the user is trying to access google.com. Can he or may get the IP address for the servers? What the DNS server will do, DNS server will be having a database of the nearby geographic servers. I will get a nearby geographic server details so that my traffic will go and talk to a APAC servers. Rather, if I open a Google website, If it goes traffic all over from Kanyakumari to UK or US, then giving back from there to here, it will induce the latency. You agree? So whatever you access it here, it has to go nearby geographic location. That could be somewhere in Chennai, or somewhere in Mumbai, somewhere in Hyderabad. Then you will be having a very fast response. You getting it? So this is the main reason we'll be going with this region, this subnet. And if you look at this picture, this region is Europe based. That is somewhere in Europe, and Europe West is Europe. For APAC, if we consider, the India as a region, and from Kanyakumari, Chennai is a nearby zone. So to avoid latency and increase the performance, we go with this setup. This is the way the Terraform code looks like. So Terraform, what we discussed so far, Terraform is an open source tool developed by AICTE, where you can define the operations using a declarative language. When I say declarative language, if you wanted to deploy anything on a cloud computing platform, you will be writing a script here. So that script you apply to a Terraform. Terraform will call the APIs to the cloud computing platform, then immediately the resources will get deployed. You're getting it right? So this is the way typically it looks like. And so if you wanted to deploy a computing instance, so deploying a computing instance in the sense, deploying a virtual machines or a compute instance on a cloud computing could be done in many ways. Cloud computing can be accessible. The easiest way would be on a web browser. You can go to a web browser, you can go to a console, you can develop, you can create a computing, you can deploy it. You can deploy it in a fraction of a matter of like a 60 or 50 seconds or 1 minute, it will get deployed. But if you deploy for 1 or 2 servers, it will be fine. If you want to deploy for 100 servers or 1000 servers, manually doing will not work out. So that's the reason we will be defining it here. If you look at this code, here you will be defining which operating system I need and how much disk I need and which is a network I need. Everything I will define here. So this is the way you define. This is a Terraform code. After you define this code, you just apply it. Then it will go and call the APIs from, because Terraform has equivalent APIs for all the declarative query whatever you do here. The moment you apply it, go to a Terraform provisioning side. Then Terraform will call the APIs to the cloud providers. The cloud providers will deploy a resource. And this is the way it looks. And the exercise what we do with the example today. We will write a code, plan, apply, evolve. So this part we'll do a lab. We'll discuss more. And yeah. This is a typical cloud computing infrastructure looks like. If you want to have more idea about the cloud computing, and we will discuss how these subsea cables are laid down. We'll discuss more when we talk about the serverless today on the second half. And this is the way I was discussing about the regions, zones, and locations, right? And see, like in India, we are sitting here, right? In almost here, the tip. When you wanted to operate a cloud computing instances, so rather you go and access somewhere in the US or UK, it will internally induce the latency and poor performance. Rather, what you can do here, you can create your computing platform in the nearby network, nearby region. So that you can go with the highest performance. So infrastructure doesn't mean only to a computing platform. It has inherently package of your networking, security, and database. So that's a main idea I'm highlighting here. This is the way typical cloud computing platform looks like. Be with any cloud example you take, Azure or AWS, and these are still completely defined with multiple regions, zones, and edge locations. So any doubts? The Terraform and the lab, what we plan to do here today. This is actually the lab. So the lab would be we will be creating a compute instance in the GCP cloud platform. And the moment you run a Terraform code, you will see that computing instance are getting created. And inside the computing instance, we will be developing a one web application. We will be putting a Flask and developing a web server. So these things, getting a computer installed, or when I say getting a server installed, and getting an operating system installed, security patches, then on top the platform Flask installed for a web application development, then assigning IP address, assigning a memory, assigning a storage database. These are all things if you do manually, you need to do it manually for everything, like creating a compute engine, assigning a network, assigning a database, assigning a hard disk. Then after having that computing engine installed, you need to install the operating system. After the operating system, you need to install the platform, as I said, like a Flask. Then you will be installing your source code for a web server. So rather you do this multiple iteration, what we're going to do here, we'll write a small Terraform script, then we'll apply that script into a Terraform app, whatever you install on your PC or into a cloud computing platform. When you apply that, how it will call the APIs and whatever the iteration, what we are expecting needs to be done, how it is getting installed. And right after 1 or 2 minutes, you could see all these applications getting installed using a Terraform. By looking at the logs, we see how the queries are running in the background. Are we good now? Okay. Shall we take a break now?
Yes, sir.
We'll take a break, and after a break, we'll do a lab. And if you have any questions, feel free to ask me. Otherwise, we can continue with the second round. Any questions you have about the cloud computing infrastructure or Terraform? There are two ways, right? Either you understand everything, otherwise you don't understand anything. Whatever it could be. Once you do a hands-on in the second round, we'll get more idea. We'll catch up. How much time? Yes, ma'am.
Actually, what we will be doing is we'll be virtualizing that device.
Right.
So we'll be creating virtual machines. So as we are using Docker here, we won't create virtual machines here.
So,
We'll be creating containers instead of virtual machines.
exactly. So what actually we're doing it here, when you go with a computing platform inside the cloud, the computing platform also there are multiple categories. Starting from a bare metal, like a physical server, then you go with the virtual machine, the second category. Then you go with the third category where the containers and Kubernetes, Dockers will come. Then fourth category is serverless, which is very latest what we are dealing with today. So the question what you are asking is the third category. So when I say third category, more about the Dockers, containers, virtual machines. What actually the Docker does, when we are installing a physical server, we must install a server. Then we will install the prerequisites like a .NET framework or SQL database. We install the prerequisites. Then we will install our application as a source code. What this Docker does, the moment first time when you install these prerequisites with a operating system, your SQL server, .NET framework, whatever the application you install one time with a virtual machine, you can package that using a Docker. So when you package, that is called as a containerization. So that will be called as a single image. When I say single image, you deploy that image into the cloud computing platform. So once the image got deployed, that image will come up with the operating system, the prerequisites, whatever you installed already, so that you can start your production work right immediately. You don't want to repeat the same prerequisite work again. So that's the difference between virtual machines and containers and Dockers. That's it.
We'll be creating the containers above the virtual machines.
Yeah, above the virtual machine, that's right. The end of the day, the platform is a bare metal, then you have hypervisor, then you have virtual machines. But the technology advancement, we are not touching these boundary layers. So whatever you do, the end of the day, you are doing in the physical server only. The console, what you are doing, the way you are doing, that is actually a different. When I say serverless, doesn't mean like server doesn't exist. Server is somewhere exist, but what we are doing, how we are operating, that really differs. You got an answer? Right? Any other questions? Alright, then we'll meet our break. DevOps engineer for SRE, mostly they do operation using a command line. So command line you can access most of the features which is not exist in the GUI. So the third access will be an API integration. You want to integrate the cloud computing with any existing applications from your infrastructure, you can access it, right? The three ways you can access a cloud computing platform. So once you get access, you will be accessing using a cloud computing command line platform. You will be doing a Terraform operations, whatever we discussed so far. You will be creating a cloud computing instances. You will be creating a network, and after creating a compute engine with the network, you will be deploying a web server inside the compute engine. So we'll do a Flask web server installation, then we'll be running a curl command. So you see when you run a curl command, we'll be getting a hello world reply from the web server. Are we good? What I'm trying to say? Once you have access to the GCP cloud computing platform, so cloud computing platform itself, you can access a Terraform. If you are accessing it from a local PC, you need to install the Terraform software here. So rather we do it here, we will directly access it from a cloud computing console. So accessing the cloud computing, three ways we have access. Three ways of accessing. One is the GUI, other one is the command line. We'll be opening a command line and we'll execute all the Terraform conditions, whatever we discussed so far. And we'll be deploying a compute engine, web server, then we'll execute a command, we'll see how the web server responding back. Are we good? So once you open your browser, just log into ce dot. I will connect my laptop in a while. So internet is working for you, right? What you can do? Okay, what you need to do here? So just open a Google site, Google website. You see the Google search engine. So type ce.quicklabs.com. Let me know once you're able to type or access it. Is it visible? CE, C for computer, E for energy, ce.quick, not QUICK, it's QWIK labs.com. And so what is it? Quick lab. So we have this is actually for ce.quicklab. So you can just maximize this. Is it visible? Just go to a browser and open that. C.quicklabs, and once you do that, you will get just go log out, and you see this page, sign in. You're getting it actually? Are you? C.quicklabs. I mean, don't go to a Google search, so I confused you. Rather, you just go to a browser and type this c.quicklabs.com. Yeah. So once it asks you to sign in, just sign in with the email ID which you give me for attendance. I given access to your IDs. You give your child your email ID. Just type your email. Just sign in. No, the second one is give your sign. So you are from veterinary college, right? those who doesn't want to access from your university ID, you can give me the personal email ID so that I can provision access.
So this sign in to be like and give accept. Go to code. What's your name?
Yes, there is a solution. Last is it?
Appreciate.
I given access to when you use directory. I give access to you first, verify from your ID. And this is the bottom. Is it on? Is it on? Your ID. Just go refresh and see. You're getting another. How about you? So once you log in with your ID, you will get a lab like this. Do you see the lab like this on your page? If in case you are not getting it, so probably the faculty is given access. Students are waiting you for login. Once you have this page, you can start the lab and show you what needs to be done. This is that. Yeah. And don't follow that skill book. That is for the different jihad. And I'll give the lab which we need to do it now. So give me a couple of minutes. I'll just complete the access part for other people. And so these two email IDs. Can you check now? You got it? Okay. It is anxious. I think I have given access to almost everyone. Can you verify now? And once you have logged in, you could able to see this lab. Is it available for everybody? If not, just do a refresh. I added a couple of email IDs now. Just refresh, you're getting it now. And those who get access, I will come to your desk. So till the time others can start. So what I'm asking you to do, this is the one. How do I do it? Okay, so those who are having access, just do a Google search. So this is the URL. Terraform GCP deploy class web server, and you will get this link. And those who yet to get the access, I will come to your desk. So let others start. And once you have this open, this is the actual lab. What we're going to do it now. So how do we start the lab? Okay, I will go back. So go to Google search, do Terraform GCP deploy Flask web server. Once you do such, you will get a first link. So deploy basic Flask web server using Terraform. Is it happening for everyone? It's a Google search, right? And now if you open the first link, here are the steps we will be doing it. I'll walk you through the steps what we're going to explore. So till the time we'll start the lab. So this is the lab, what we are getting it. Can you switch back to the lab page? Just open and you need to start the lab. So just follow me, just click, do start the lab. Once you start the lab, you will be getting the credentials to launch the lab. So basically, this is a skill boost console where I given access to your email IDs. So you'll be having access to the Google Cloud Console. We'll explore, I mean, not only with the Terraform, we'll spend some time to understand how the Cloud Console looks and appears for you. Anybody here first time accessing Cloud Console? Students, have you accessed any cloud before? Are you doing first time? Okay, fine. Be with me. And do you get this page? Those are having access? Huh? Once you start, okay, those are yet to get this page. I will come to your test. Here, just right click, open. This is new private window. If it is a Chrome browser, it is an incognito. Right? You need to just right click. If it is a Chrome browser, it will be an incognito. Select. I do Chrome. This is a Chrome. It's an incognito. You get it? Open an incognito window. Once you open an incognito window, it will ask you for the username. So username, just go back to the same page. Here you see the username and password, right? Just copy the username and place that username here. Same, copy the password here, and yeah, see that. I already started a couple of sessions, so we're giving error. I just close that. And once you log in, you get a page like this. Is it happening? The Cloud Console page. Anyone got access to this page? You got it? So starting, okay, starting is still happening. So those who started, you got it right. Give me a minute, just ensure. You can spend some time to navigate and you getting it right. Yeah, just open console, just right click, username and password. Just give username and password, you are just logging, right? Just copy the first username, first password. Copy the first username and first password. Copy the first username and first password, and probably like once you get access, you see the Cloud Console as it is. You see that this way it will appear for you. And okay, fine. Now I will come to your test. You ready? You still? Can you start? It is happening now, right? So what do you do? Just start. Start. Okay, come here. Can you type your email ID and just add student? yet to get access, let me know. Those who already got the access, see how many of you yet to get access to this console? Can you just raise your hand? I will come to your desk and verify the part. Are you on the same page? Are you on the same page where I am? Anyone need to get access? Anyone? So you got access to the cloud console and a web browser. You need to get access. You need to get access. Access good. Yeah, very good. Do you know the email ID where you know the password? Same for you. And if you can't remember your password for email ID which you given, then give me a new email ID which you know the password that you have. See that quick class. Happened for you, right? I got it. Might be the email ID which you provide. You're getting it right? Okay, you can go and refresh. So those who got the access, we can start the lab. Those who yet to get access, just raise your hand. Like others start, I can come to your desk and we will do the lab. So rather waiting. Okay. So those who get access, just look at the screen. This is the way the cloud console of a Google Cloud platform appears for you. And the same way you can access any cloud console like a AWS or a Azure. The way you can access the cloud computing could be a different ways you can access. So this is the one way, the easiest way you will be accessing it on a web browser, the UI. The second option is, you see here, there is a activate cloud service. Did you see that? Can you click that? when you click that activate cloud cell, you see one more console platform it is getting open at the bottom. If you continue here, so this is basically you are activating the one more console to access the GCP cloud platform. So as I told you, there are three ways you can access it. One is using a web browser. The second one is using the command line. So to open a command line, this is the way. Once you click that open cloud shell, you get this black window. Hope everybody got it. So just to avoid the confusion, let's maximize it. Just see here, open a new window. Once you click, you will see the same command line window is getting open in the next tab. So when I say this command line window, what is actually it is happening? The moment you activate the cloud shell prompt, when I say you activate the cloud shell, so GCP cloud is activating a virtual instances for you to to access the GCP platform. So the moment you click, you see there a script is running. You see that computer resource is getting allocated. So this is the way the G Cloud console is activated for you. So you got a second access, which is black color window, the command line prompt. So the two ways. One is the one way. The second way. The third one is like if you want to control anything over API, so you can use any API tool. You know Postman. Do you know this tool API tool Postman? Or I forgot about the Postman. Like anything, if you wanted to integrate the cloud application to your on-prem, and you may need like I will just show you one quick example. From there you can start it. Let's have a clear understanding about what we are actually doing it. So assume this is a GCP cloud platform. So I'll make it as a GCP. I mean, people those who are totally new to the cloud platform, just try to understand. So to access the GCP cloud computing platform, not only the GCP, any cloud computing, if you consider, there are three ways you can access the cloud computing. So the first way, this is the first way. This is a web browser using your own browser. You're accessing the web UI. Second one is the command line interface. The third one is the API. So the first one is the web UI. Second one we go with the CLI, the command line interface. The third one is the API. So this web interface and the CLI. This is more for developers, those who are operating it. Those developers are practitioners or a DevOps engineer or SRE. Those who wanted to control or those who wanted to compute anything with the GCP resources. So these are the two different ways they can access the GCP cloud. When I say GCP cloud, inside the cloud, again the four core components, right? We discussed the four core components. If you remember, the computing platform, then networking, then storage and security. You remember that? Say like this is the computing platform, and this is the networking component, this is the storage or a database, and the last one is security piece. These are the four components which exist in any cloud computing. So consider an example, we are using GCP Cloud Console to access anything, any resources on the GCP Cloud Console. We have two options. One is the web interface, other one is the G Cloud platform. So G Cloud platform, when I say G Cloud not necessarily from a cloud interface itself. If you install the G Cloud SDK on your local PC, you can access it from your system itself. For example, this is my local system where I had accessed G Cloud. So I already installed the SDK on my PC. So I can directly access it from my laptop to a console directly. Whereas in your case, you don't have that particular SDK installed on your computer, so that I requested you to access directly from a cloud console. However, keep it that aside. We have two ways. One is web interface, one is CLI for users to activate. This is a user, and this is also a user. When I say user can be a developer or a SRE or like a practitioner or a DevOps engineer. Then application interface. So application interface, what does that mean by application interface? Say like this is your on-prem or your enterprise where you have couple of devices, couple of applications. Say like you have a database and you have a front end or you have a back end servers. Then if you wanted to have a connection happen between your database to a cloud computing platform, and I'll give you one example. Say you having a Gen AI model, or you are using a foundation model with a cloud computing platform, maybe with a GPT-4 or a Gemini, so whatever the example you take, so that exists here, the foundation model. So they are pre-trained with the generic data. For your use case, you are going to train a model, or you're going to fine-tune a model with your own data, what have it in your database, what you are having in your on-prem enterprises. If you wanted to do such integration from your applications to a cloud computing, this API is needed. So this API, it can be a REST API, or it can be a gRPC API, remote protocol APIs. APIs could be anything. Are we good now? So before we getting into the cloud computing platform, give me the context. What actually we're going to do it here, do it now. And to access the cloud computing platform, we have three ways to access. One is the web UI, other one is the command line, third one is the API. So these thumb rules remain same for any cloud platform if you go. It is irrespective. Now to access the cloud computing platform, we open in the web browser, then we access the CLI prompt. When you see CLI prompt, we want to explore the CLI also. Then API we discuss. So in API, how we going to discuss here? Let me just open. Okay, so API I'll just draw it here. Say like this is the GCP platform, and we will be going to do with the Terraform, and we will be having a so the Terraform actually what we are going to do now. This is GCP, this is a Terraform, this is the practitioner, or this is actually you. So whatever script you are going to do it here, you will be writing it in the Terraform. Then Terraform, what it does, it is calling the API to the GCP. Is it clear now? So what is the role of API? So API is basically application programming interface. It could be from any application what you are already running, or it could be like a API call from a different tool. In our case, the automation what we are going to do here, we are going to write a script on a Terraform. By executing the script, the Terraform is going to call a cloud console in this API. So now we going to access all three consoles now. So first console you already access. So this is the UI console. So if in case you are accessing first time, you can just navigate along with me. I'll show you some things. So this is the way the cloud computing platform looks like from a GCP side. So it will give you information about your project name, your project ID, your project details. When I say this project, so GCP is a one platform which will be utilized by many customers or many users, right? Say example, in our classroom itself, we have around 40 people accessing GCP cloud. How the GCP will differentiate the individual user or individual customers with respect to this project ID. So they will do a billing on the project ID, they will do a billing on the API consumption, how you are consuming an API, how frequent, your utilization will be charged for you. Is that clear now? So those information needed. If in case you are having some issue with the GCP platform after you deploy it to a real-time work, real-time production, then if you want to raise a support ticket with a cloud provider, then you need to share this information. The moment you call the help desk, they'll ask you what is your project ID. Because every troubleshooting or every access will be traced with respect to your project ID. This is a name tag for your work. Then API utilization. So this is a very graph you could see how much the API is being utilized. Because all the cloud providers, they will charge the consumer with respect to the API consumption. Are we good now? API consumption. And now if you wanted to see G-Cloud status report, say if you wanted to say like, do we have any downtime in the cloud platform with respect to GCP? If you click this link, you see the whole dashboard, and it will say like what are the things that are active. If something is down, if something is not working, and some region if you are trying to create something, but something is not responding back. If you want to understand any production issues going with the platform level, then you can see it in the status. This is basically a monitoring dashboard. Will give an idea. So what is happening in the cloud. And now if you go to these options, so here you will be getting all the options. So when I say all the options, our primary focus will be a compute, storage, networking and security. And in this lab, we will be creating a compute engine and launching a web server using a Terraform code. Now it's a brand new instance, we haven't created anything. We'll go to a compute. You are there at the compute engine, right? When you click a compute engine and you see this page appears for you. This shows completely a blank window. That means to say no compute engine has been created. If in case you wanted to create a compute engine, this is a place you will be manually doing it. You will create an instance. I mean, this is applicable for any cloud providers. You will be giving a name for your instance. Here you will be giving a region and zones. Regions and zones I told you morning, right? From where you are accessing, accordingly you will select region and zones. See here, we have a US region, Europe region, then APAC region, and Africa regions. You can select the region, you can select the zone, whichever the zone you want. If I go with APAC and say like APAC is which is our nearby, I'll go with APAC South. APAC South is Mumbai, and zone if you go, we have a South A. It could be a Chennai, Hyderabad, and Chennai, three zones. And here you will be configuring which computing platform you need, how many CPUs you need, how many memory you need, what's the platform, which operating system. If you wanted to have anything more customized, we could be able to do it here. But we are actually not going to do it manually. This is the way typically you create a cloud computing instance. And while creating a cloud computing instance, it will ask you which traffic you are going to allow and which network you are going to configure. So this is the way. So rather than we create it here, we're going to create this using a Terraform. Just for you to understand, there is no compute engine exists, no compute platform has been created. Are we good now? And so similar way, if you want to access the Kubernetes, we were talking about a Kubernetes Docker this morning, right? This is a place where you can go on to a Kubernetes orchestration for a containerization. And cloud storage, again computing we discussed, storage is a place where you will be saving your file, like your hard disk, your extended hard disk. And you can save your structured data or unstructured data, or it could be anything with images or media files, anything you can save it here. And BigQuery, it is again a same like a TBMS engine which is running on a cloud platform, which can analyze your data, whatever you save it here. And VPC network is a place where you will be doing an interconnection from a cloud computing to your on-prem, or you are running something on a GCP cloud, you want to interconnect with a Azure cloud or AWS cloud, where you can do it here. And the cloud functions that we discussed during the serverless computing platform. But how? Just giving a rough idea. So we started with a laptop example, right? If you want to buy a new computer, you look for a computing and storage, security, and network. Do you all remember that? We started with that. The same which I am showing in the cloud platform. So cloud platform is nothing different. So what you have in the local laptop. You have a compute platform. So compute platform, we have a different categories. With respect to your requirement, you can go with compute engine or a Kubernetes engine or a cloud run or a cloud function. And it's a computing category. Networking category. Then security category, you will go all with IAM and IAM. This is all about your security stuff. Who needs to have access? Which user account you will create? This is like IAM page, authorization settings you will be doing it here. And networking, security, computing, and the database is all about your BigQuery. And same like a BigQuery, we have a lot of different, like a databases. With respect to the application what you are going to develop, we will be calling those DB. Are we good? Just a high-level idea about how the cloud computing looks like. This is the way it is almost common for any cloud platform. Now let's go to G Cloud. And little commands, if you type clear, your previous commands will go away. We'll get a plain page. And so now we do here G Cloud auth. And I'm just typing for you to understand the G Cloud auth login list, just to ensure this is a web console. This is the GCP project what you are accessing it. This is the project ID. And this is your student login, right? This is the student login. Now, this student has logged into this project, so whatever you do it here, these complete things are captured in the log server, so that everybody can go and understand who did the changes, when he did the changes. If somebody wants to revert it back, they can do that. And if administrator want to restrict your access also, that can be done. Now, just to verify the same user ID, okay, just go and check G Cloud auth list. If you see, then you could able to verify this is the student login here. Now, I go back, export images, and just GCP. Alright, now the exercise what we're going to do here. So this is the Terraform, and this is the This is U. Basically, this is U, and this is the Terraform, and this is the GCP console, right? And what we're going to do here, we will be writing the Terraform script, and after writing a Terraform script, there is a procedures we need to validate, plan, and apply it. So there is something like a steps we need to follow it, and this we have it here. I will just show you. Yeah, this just a quick recap. This is actually what we're going to do now. We're going to write a Terraform script. So the Terraform script, what we're going to write it now, that is going to deploy a compute engine. Along with the compute engine, a Flask web server you're going to deploy. So that will carry about your computing platform, which operating system, which network you need, and how much storage you need, and also your web server, the Apache server, Flask web server. Then you running the curl command, you will be getting a hello world response back. And so that is the code what we will be doing it. The moment you do a plan, when you do a plan, see the code whatever you type until you do a plan, your Terraform doesn't know. So for which platform you are going to execute the code. So Terraform, as I told you, this is a common platform which is having access to almost like a 70 Terraform providers. So now GCP is one of the Terraform providers. The moment you write a code and do plan, while writing a code itself you will mention that I'm going to run this code. This code is for a Google Cloud platform. Once you do write a code, then you do a plan. When you do a plan, what it does, it will download all the latest modules from a GCP Cloud registry. Then it will get an understanding about, okay, your code is equivalent to which API calls it's supposed to make for a GCP Cloud. Then the moment you apply, then the API calls started calling to a GCP Cloud. Then the moment you apply, save it, then you could see, in the console itself, what is happening with the GCP platform, how the computing engine is getting created, how your Terraform code is getting converted as API calls. When these API calls are called out to GCP platform, how GCP platform is responding back to you. Is that clear? Same example, and this is the same flow. This is actually what we're going to do here. In the infrastructure as a code, we are going to write a code, basically we are going to execute a code for creating a compute engine, creating a Flask server, launching a web server. Once you have that code created, you do a plan. When you execute a plan is kind of a debug or executing a command in the Terraform console. The moment you do a plan, it will fetch all the registry files from a GCP cloud. The moment you apply, you will start executing the APIs. When you start executing the APIs, then GCP will allocate the resources. Alright? So now, any questions we have? No questions. Pretty straightforward, right? So let me put this clear. So now what I do, and if you wanted to see the Terraform version, and if you wanted to see like what Terraform version, you could see the Terraform version install here is v1.5.7, and so this you could see like it is on the Linux AMD 64, and since we are accessing the G Cloud console, which is default coming with the Terraform, if in case you wanted to do this operation from your local computer, you need to install the Terraform software from Terraform side. Makes sense, right? Now this, when you activate the Cloud console, basically an instance is getting created for you. So from that instance you are accessing it. So now we have a Terraform already installed. So no worries, you can start the Terraform code. Now to start the Terraform code, here is the place what we discussing. And you have this page link, you can follow there. And here, if you have these, this is the task we're going to do, deploy a basic Flask web server using a Terraform. So to install a basic Flask web server, you need to have a compute engine, the computer, basically a server, operating system, network, then you'll be having a web server, the Flask web server. These all things needs to be installed. So rather than we doing it manually, we'll be completely doing the script. So the initial steps which has been already taken care by provisioning the lab, now we can directly go to a create directory. So create directory is a place where we will be creating a script. This is our script. Do you see the screen? Create directory. What you can do, you can just directly take this command and put it over there rather than me writing it. But the idea remains same. So we have a Terraform script. We're going to make it. Once we execute the Terraform script, it is going to make an infrastructure provision at GCP platform. So now GCP platform VM instance page, it is completely empty. Rather than we doing it manually here, we are writing a Terraform script, which is a one-time effort, and you can even execute it anytime, which will deploy an instance here. So we'll go to a cloud console, copy this command, and if you want to understand, just read it out. So you are making a directory, and you are changing a directory to the directory what is created. So I'm creating a directory, make directories, basically opening a directory called TF tutorial, and I'm just changing directory to the same directory path. Are you guys with me? You able to execute the command, right? And you see the change. Now the directory got changed. It was with the group before. Now it has moved to a directory. Now the next command, what I'm going to do here, I'm going to make a yes. Oh. Okay. To get a previous documentation, go to Google search, and yeah. So this go to Google search engine. That's a good thing. So go to Google. Yeah, those who yet to get access to the doc, just type Terraform GCP deploy Flask web server. Let me know once you're able to get the page open. Terraform GCP deploy Flask web server. We're going to deploy a Flask web server using a Terraform code. You getting it? Hope everybody got right. So the moment you open, you get the first link. So this is the first link. When you go to the first link and you get instructions. So the first step, I'm just creating a directory. Creating a directory is like creating a folder, like how you create a folder in Windows PC, creating a directory at Linux. Then I'm creating a file. So the file name is main.tf. Always a Terraform file which ends with .tf. How we have a Python extension, similarly we have a TF extension made for a Terraform file. I'm creating a file, so Nano is the editor. So like how we have a Vim editor for Linux, Nano is one of the editor. I'm using Nano editor for like easy to execute. When you type the next command, you will get this window. Do you see that? Simply you're creating a text file with the name of main.tf. And so what you can do, copy the next script, and rather than blindly copying it, just see this script is for create virtual private cloud network and subnet. So before creating a compute machine, you are creating a virtual network. I told you right, when you buy new computers, before you connect to a Wi-Fi network, you should have a Wi-Fi network installed at your house. The same actually I'm doing it. I wanted to create a virtual private network. Then the next step, here I'll be configuring a computing platform. See, virtual computer, let's see what it says. It's not a code, right? It's basically a declarative language. What Terraform can translate this declarative language into an API calls. It says, okay, this is the name you should create, and I'm creating auto subnet files. This is the MTU payload size, how much payload size it can go with, and this is the name. This is the subnet I'm giving CADR, the classless IP address subnet. This is US West is the region I'm creating a subnet, and this is the network ID. Basically, this is very simple, right? What we are going to do it. If we wanted to do the same thing here with the web console, and basically we go to a VPC network. This is a VPC network. When you go to a VPC network, and when you start create, don't do that. I'm just showing the example. When you start creating a VPC network, it will ask you everything. Give a name, give a MTU size, and what is the subnet, what is the region. Whatever you do it in the web console, the same thing I'm just declaring in the script, right? You see the MTU size, the name, the subnet region. Copy this, go back to your G-Cloud console, just to enter. Control V, Control C, Control V. Is it happening? Just give enter. Don't save it. You copy, you paste it here. So what we copy? We copy the network script, we paste it into the Terraform console. Now go back to the same, same manual. So the next step would be you are creating a compute engine. When I say compute engine, this time you are creating a virtual machine. You are creating a virtual machine. What you can do here, and copy the script. So here the virtual machine, it says like give a name as class VM. So this is actually, rather than you go here to a compute engine, when you go to a compute engine VM instance, If I do manually create here in the web console, it will definitely ask you those things. Give a name, give a region, give a zone, give operating system, give a subnet, everything. It will ask you to manually do that. Rather than I do it, I'm giving it here. What is the name? What is the machine type, zone, and I'm giving a like which operating system, Debian, everything I'm giving it here. And along with that, I'm doing a startup script also. The startup script, so right, this is basically a sudo command to get install this Python 3 pip and also a flask. This right, you basically a pip install and a flask install. What you do. So rather than I just create a server, create a install operating system, then install a pip, then install a flash server, rather than I doing it manually, I'm getting all in one script. It's a one-time effort. Once you do that, then you will be able to create a number of instances. Copy the script, just understand and do that. Go back to the same cloud console platform, do enter, control V. Once you do enter, type control X. Press control X to save the file, control X. It will ask you for yes. Control X, control X. What did I do? Is it responding for you? Control X, and it is asking why. Just do a refresh. Control X. Okay, give control X, it will ask you for yes. Control X. Rather than I give X, I give command X. It's a problem of mine. Is it happening? Control X from you. Your Windows PC not happening. Control X is asking why for to save. Is not responding. It is Control X. This. For others, it is happening. Control X.
Yes.
Control X. Yes. Save the file, US. So once you save the file, you see that it is happening at your screen, right? If you wanted to view whatever you saved, is it happening or not saved? If you wanted to view the file again, you do an annotated. I mean, for me not it's saved. I think I'll just do a recopy, and I'll just go back. And copy here. Is it happening? You're able to see the file? So if you wanted to see whether it has been saved, you could again rerun the command. You read the file, Control X. Is it happening or not? Not saved. Not getting saved. So that means you say like when you do a nano file, say I'll execute something here, then you need to do a Control X. It will ask you for yes and no. You need to give a capital Y. So Control X. You go with the same thing. Nano minor PF. Once you copy and pasted the command, do a Control X. And basically do a Control X when you do any changes, it will ask you for yes or no. You need to type yes. Is it happening? After
giving yes.
after yes, it is after yes. If you go and read the file, it is not appearing for you like the text. Then that means it. Okay, then we'll do one thing. Okay, Control X. I'll just do one more time. I'll just try to delete. You getting it now? Getting it? You getting it, sir? How about other people? Are they getting it? You got it, right? Control X. Freeze, I think,
like that.
So, anybody is not getting saved? Everyone got the file saved, right? Nano file, clear file. Let's. So now what we do, we had executed a file. We had created a Terraform file for creating a network and creating a compute engine. Now we go with the Terraform. So Terraform, as I told you, when you want to execute, it had these iterations, right? First you need to init, then you need to plan it, then you need to apply it. Init, plan, and apply it. So when you do init, you basically download all the registry files with respect to Google Cloud platforms. When you plan it, it will execute and show you what are the APIs are being called out, what is executed in the behind the screen. It will display everything on the CLI. Then when you apply it, the actual creation is happening. So let's go and see. We go back to our CLI and go to the manual. So here is the place, right? So we created a script for network. We created a script for a compute engine. Then we go and start a Terraform init. So Terraform init basically just to download the registry files which is respect to GCP cloud. If you do it for other clouds, it will do accordingly. The moment you do Terraform init, you could see like initiating the backend. The Terraform initiate is happening. It is downloading a file from a AICTE Google. AICTE is that is the Terraform backend. So Terraform, if you wanted to do Google it, Terraform. So Terraform is fight AICTE. AICTE is the one who will be giving a Terraform product to people. And HCL is a AICTE configuration language where we will be running. This is actually what we writing it here. What we have just copy and paste, that's the HCL language. It's a declarative language for infrastructure automation. The moment you type infrastructure init, you see what has happened here. It's just installing all the files or registry files with respect to only a Google Cloud. So when you do such way for other cloud, you will get to know like other cloud registry files are getting downloaded. Go back here, and this is fine. Then you need to plan it. So plan is very important. When you do a plan, so in a Terraform plan, it shows what your script is going to do in the GCP cloud. Let's see, when you run Terraform plan, it will show you exactly what your script is meant by. It is going to create a compute engine with these default settings, whatever you define. Whatever you define, that will take into consideration. Other things, it will consider the default settings what we provide. And also the network interfaces, whatever you predefine, the MTU sizes, the network name, and VPC network. Then we'll be having the IP subnet, whatever you predefine, everything, whatever you predefine with a script. So now this is fine. Terraform plan init and Terraform plan is fine. Now Terraform apply. So Terraform apply is the actual command. When you execute a command, your respective operation used to happen with GCP cloud. So after the apply, so here we used to see the new instances getting created with the Flask. So whatever we run on the script. Now we just go and do a apply, Terraform apply. And the moment you apply, it will ask you, is it happening for you? This is also. Yeah, Terraform apply will ask you, will perform the following actions described above. It will ask you your confirmation. It will just show you what it's going to create. It is exactly what it showed you before the plan step, right? The moment you initiate it, then you did a plan, you're going to do apply. It will re-verify you. I'm going to create, this is the script what you have given to me. We given to only 2-4 lines we copied and pasted. Remaining everything, we took it as a default one. Then you enter the value as yes. The moment you give yes, you just read out what is happening on the script, it will show you. backend, the network is getting created, your computing instance is getting created, your class PM is getting installed, your IP address is getting assigned, your SSH is getting enabled. These are all the operations what is happening actually in the GCP. Now whatever you see it here in the script, your Terraform is calling the respective APIs to the GCP cloud platform, and GCP cloud platform is actually provisioning what you require. Is it happening for you? Yeah. You getting error? So how many of you got error and how many of you could successfully run the command, create the instance? And when you run the command successfully, when it says apply complete, you could go to a VM instance page, say go to a cloud console, go to compute engine, and where you see the new VM has been created. How many of you got this page? The VM created? Yeah, all of you, right? So other people, are you getting any error or still happening? Error? Okay, I'll come to the people those are getting error. Now those who already got this instance, now you got an idea like the engine has been created and VM has been created, come up with a web server, what you had already launched into the script. So we need to access these servers, since it is a Debian OS, we need to access it in a SSH or a CLI. To do that, same prompt if you go, there is a one more firewall rule you need to add into the Terraform script. So here, where we are. So we did here, right? Terraform apply we did. Then run a web server on a GCP cloud. So to access SSH, you need to allow this firewall group. So basically, I was enabling HTTPS traffic to the particular web server. Go back to a console. Go back to a console here. Again, go to a same file. Nano same file. Go to a same file and add that firewall script. Those who got a VM instance, add the firewall script here. Save. If you wanted to verify, you can just verify that you see the latest one you have added. Firewall I have added here, so you can see that rule has been added. Once after adding the tool, you need to run the Terraform apply so that the latest changes what you added to the script, which will get applied to the server. So we just created an instance, launch the web server, but to access the web server, you need to open the firewall code. So again, we are doing a modification into the Terraform scripts. After adding the firewall rule, we could able to see. So after adding the firewall rule, you need to apply a Terraform apply again, and just follow these steps here. So I am in these steps. After allowing adding a custom SSH rule, I'm rerunning the Terraform apply. So once you complete that, you can just go back to a same cloud console web interface. Go to compute engine to navigate. Go to a three dots. Go to compute engine. So once inside the compute engine, you could see this class VM. Is it visible to everyone? Those who are with me. Just try to open in SSH. When you click SSH, so basically you are opening that VM using using the SSH console. So ideally after this firewall rule, once it added, it has to open. Let us see. Once it opened, you can launch. So let's see. Is it happening? Those who are with me at this stage. So once you have that SSH open, it will show you now. You log into this VM. See the difference. You are not no more into a G Cloud console. If you look at the browser, so there you are into a G Cloud shell, the G Cloud console. Now you are into a particular VM you log in. Basically you are logged into a Debian OS Linux PC, Linux server now. So now to run that particular script, go back here. So again, we need to run a small script, right? So you need to create a one more app.py file, basically a Python file you are creating it. Adding a script says that any curl command it has to respond, any HTTPS request it has to respond back hello world. Copy the command, put it here, and just hit 2 times. Then save the file. Control X. I'll just double check. Okay, this will not save site. I'll just cancel the file.
Copy the files. Then you go up control S. Yes. I will just copy this file. However, the string program I copied and we will try to save it. It's very beautiful.
Is it happening? You are able to install a web server, the Python 3? Or you can install these You see, getting the curl command response is all over. You getting it? Okay, fine. You need to open the SSL in two different consoles, and you getting it. Okay, fine. You getting it at the very second time. Okay. If you
What is it like in a
Say got it? Seriously? Sir, I'm operating from a cloud console. Please give me an online instance.
Getting error after this.
So those who completed, we can take a break. So we'll meet by 2 p.m. 2 p.m. At 2 p.m. Machine learning. Okay, I see your registration. You are running.